So we're finally getting into the shortcuts for derivatives. And the one shortcut we know for a derivative of a function, and we learned a rule yesterday too, last time. If I have a function that looks like this, what is its derivative going to be? Yeah, the power comes down, and this power goes down. It's kind of nice. So the power comes down, and then it goes down by 1, 11. Does it matter what this is? Not really, no. Okay, I like it. So anything that could be written in this form, you can then attack it with this rule. So radicals, variables that are on the bottom, you can bring them up. Cool. So if I had, for example, what would this be? This derivative. Negative 8x to the negative 9. Good. I love it. Right. What if I put a... So what does that mean if I put something in front of it already? Like if there was 7x to the 11th power. What's h prime? Yeah, the 11 comes down. 11. 77. 10. 11. So I don't know on this problem if the issue is the c. Oh, okay. So whenever you see, basically whenever you see a, b, c, those are going to be constants.
Alright, so when I would bring the power down, it would go in front of the c and not the y, right?
Yeah, you just write it. Numbers we normally put out front.
Okay.
Yeah, so if I had, for example, f of x equals b x to the negative 1/2. What would f prime be? Nothing major. What happens to this dude? It comes down.
So it's negative 1 times
Negative 3x, yeah. Negative 1 minus 2 is negative 3. A cool little shortcut how to subtract 1 from a fraction. Kicks so much ass. When we learn anti-differentiation, we'll add 1. Oh shit. And then you just add the top and bottom. That'll be the shortcut. Right? What happens in math? Whenever you learn a function, what do you almost immediately learn right after it? It's opposite. It's inverse. So if I can take derivatives, I have to be able to undo derivatives. It's also called integration, but don't worry about that yet. Anything else from homework stuff? Yeah.
Section number 59.
59 and 3-1?
No, section 2.8.
2.8? Okay. You said 59?
Yeah.
I love it. So what's it mean for a function? A function is differentiable at some x value. What's that mean? What has to be true there?
Its slope is continuous at that point.
Yeah, the slope is continuous. So like the f prime function has to be continuous at that point, right? If f is continuous, is it differentiable at that point necessarily? Like what is the example of not differentiable at a point A? What could happen at that point? It could be discontinuous. Right? This is not differentiable at A. It could be, what else? What else could happen at A so it's not differentiable there? The main one. Yes, beautiful. Shwa. Make it there. Ah. Yeah. So if it has like a sharp edge at that point, it's a kink or a corner. And again, both of these relate to the slopes not being continuous there. And of course, the other way that's a little less in your face is if it ever has a point where the slope becomes infinite, then it's not differentiable at that point A. I like it. So they give us a function. They give us the absolute value function, which of course is related to which one of these? 1, 2, 3 absolute value functions. Yeah, 2. The second one's going to have that kink there, but you can't just say that and be done with it. They say prove it, which normally means try to do it and show that it leads to a problem, right? So what sucks? The reason I say something so controversial as I wish the absolute value didn't exist is because I need you to realize when you have an absolute value you're working with, you have to be really careful. When you have absolute values with variables, I don't have a clue what the answer is because it depends on what the variable value is. If that's 7, in fact, you need to be able to do this anyway for this problem. If x were at least 6, how can I rewrite this? What kind of number is inside if x is at least 6? What kind of number? Because what's an absolute value due to a number? It depends on if it's positive or negative. So which one of those is it? Positive. Good. All right. And what does it do if it's a positive number already? What does an absolute value do to it? What's the absolute value? 7. 7. So what's the absolute value do to something that's already positive? Nothing. If x is less than 6. Now what kind of number am I talking about? Negative. Right? And what's an absolute value due to a number that is negative? And how do you do that mathematically?
Multiply by negative.
Multiply by negative. If you don't trust this, what if you put a 4 in there? What's that? 4 minus 6, negative 2. Absolute value negative 2 is 2. Put a 4 in there. Negative 4 plus 6 is 2. There. They have the same value given the correct location. I like it. So this is why I say that. This function hides the fact that it's this and this, depending on which values of x you're plugging in. So I thought it was such a subversive, evil little function, right? It's a nice way to capture an idea real quick, but still, it's hiding this. So if you take the derivative of this function, you have to do it dependent on what the x value is. What's the derivative of this going to be? Who could just look at that and tell me? What kind of thing is this geometrically? It's a line. What's the slope? 1. So the derivative of this function is 1 because derivative is slope. What's the derivative of this one? Negative 1. Is the derivative continuous through 6? What was it here? 1. What is it here? Negative 1. Is it continuous through 6? No. All right, basically just the problem for you. You just got to capture it all down on paper now. So really, when you see that word differentiable, the quickest way to summarize what that tries to get at is the slope itself. That function has to be continuous through that point for it to be differentiable at that point. I like it. So that one's a little bit freaky. I like it. Anything else from homework stuff? No. Okay. All right. So we basically reviewed that. The other thing we did was the first part of section 3.2. The first thing in section 3.2 was just the product rule. And I'll tell you this right now, the product rule is a little lame until we learn something called the chain rule. And then the product rule is like, thank God it exists. So we got to lay the groundwork. Here's the product rule. It's an easy one to prove. We proved it last time. I'm not going to prove it again. But basically, if I have a function that's actually made up the product of two other functions, you're going to see this in a lot of other, in fact, every form has got this idea. You never take all derivatives at once. You give them all their own term. So how do I rewrite? What does this become? F prime of x. So then f got its turn. Plus. So they each get their own term. So just to show you an example of, and see if you see why I'm saying it's a little bit lame, but it's not. It's by itself, it's not lame. It needs to be married with the chain rule. Here's a classic example of this. So if I said take the derivative without foiling this sucker, that is a product rule. And if you really want to, you can identify what f is, what g is. You can write the form down. You can fill it in. But basically what you do, and here, this is huge. Okay, this is huge. This is the time to really get this in your heads. So we're going to learn product rule, and then we're going to learn quotient rule, which kind of makes sense. What do we do when it's multiplied? What do we do when it's divided? Then we're going to learn chain rule, which is what do we do when there's a function inside of another frickin' function? Whenever you go to apply those rules, the first step shouldn't involve any taking derivatives, unless you feel really comfortable with it. What do I mean by that? My first step here is going to be capture the idea of the rule. The rule says, take this guy's derivative, leave this alone, plus leave this one alone, times this guy's derivative. That's the rule. And then I start doing derivatives where I see the little primes. The mistakes, people make a lot of mistakes when they think they're supposed to be able to do, not just apply the rule, but do the derivatives at the same time. You make so many kind of simple mistakes. Capture the rule first, and then do the derivatives where you need to. I'm hoping, if I just said take the derivative of this, I would hope to God you would multiply this out first, right? But, now I can kind of check and make sure we get the same answer. What's the derivative of this guy? 2. And what's the derivative of that guy? 3. So then I get 6x, and 6x is 12x. 10 minus 3 is 7. Is that cool? Is that not cool? All right, same reaction. So you're somewhere in the middle. What do you get when you multiply this out?
6x squared.
Plus 10x minus 3x is plus 7x minus 5. And what's this guy's derivative? Yeah. So of course it's going to be the same. A rule can't change the answer. It just gives you a different way to get to the answer. Okay, maybe. So here, let me give you a couple to try on your own. So use product rule. What you guys have? Let's see if you guys get this. Let me catch up to you guys. We gotta take this guy's derivative, leave this guy alone, plus leave this guy alone, and then this guy gets his turn. It reinforces the rule. It helps you focus on a specific thing at a specific time without having to think that you have to keep it all in your head at once. It's kind of crazy. Now my whole world is this. What's this guy's derivative? 5 halves. X to the 3 halves, good. Plus this guy. What's the derivative of this business? 2x to the negative 1/2 plus 1. I love it. Kick ass. And then you can distribute and do all kinds of business. If we try to, let's see what it is. 5 halves is 4, 5 times 2 is 10. X to the 3 halves times x to the 1/2 is x to the second power. I like it, 4 halves, which is 2. Plus 5 halves, x to the 3 halves plus 1 is 5 halves. Just distribute this stuff, right? Are you guys with me? 2, 5 minus 1 is 4. At the bottom of 2 is 2. Plus x to the 5. And then you got like terms you can put together. Blah, blah, blah. Yes?
So in the book, the formula is take the function times the derivative of the function plus the function plus the derivative. So it's kind of an opposite, but it doesn't seem like it would matter, right?
No. Yeah, let's see. Oh, I see. That's dumb. Yeah. This way actually makes more sense in a minute. You'll see what I mean. But it doesn't matter. It's addition. Who cares? Yeah. F prime G plus G prime F, or F G prime plus G F prime. It doesn't matter. Is that cool? Yeah. I like it. So what do you have to do with this guy? What do you think?
Multiply by one of them, so we can only have 2.
Yeah, how many times are we going to have to do the rule kind of thing when you have 1, 2, 3 terms? They each have to get their own turn, so it's going to lead to 3 terms. You guys with me? I don't care how long I make this string of product of functions, you just have to give each one its own term. Why did I have 2 terms here? Because I had 2 functions. Now I've got 3. So the rule is going to be this guy times these, plus the middle guy gets a turn, plus the last dude gets his turn. I like it. So product rule is pretty straightforward. However many terms you have, you're going to end up with that many terms separated by pluses. So then I get x prime, of course, is just 1 plus x. What's the derivative of this? 2 plus x times 2x minus 7 times derivative of this is 4. And then you can clean that up. Yes?
We can use a shortcut by multiplying.
Not if it says use the prodigal. Yeah, I agree with you that if I just said take this guy's derivative, I would certainly multiply this stuff out. What's the point of doing it this way? Getting used to the prodigal. I like it. Once we learn chain rule, prodigal is going to become your favorite thing in the world. You're like, thank God. What I keep saying that for is, if I had a function like this, we cannot do this function yet. We can't take this guy's derivative. It is a product, but it's more than that. Isn't there a function inside of a function? We haven't learned that yet. That's chain rule. So I can't, right now I can't put powers on these. So you'd rather multiply that out. I can't put like a seventh power in there. So you're like, what's the first power? Who cares? Let me just multiply that shit out, Jeff, please. No, get used to product rule. So that when we get to the point where like, dear God, I don't want to multiply that. Are you kidding me? Write this 29 times. And just start going, it's no, no. So then you'll be like, thank God for product rule and chain rule. Oh my God. So all we're missing being able to do this problem is to figure out what to do when I have a function inside of another function. And then product rule steps in and says, I got you, buddy. You can do that. We're all good. All right, maybe. So I understand the frustration. I understand, but too bad. It's just to get you used to. The nice thing is, once you get an answer, you can go back and do it the way you want to and check it.
My question was, if I multiply x by only 2x minus 7, so I end up with having only two functions, and then take. So that would bring me a correct result, but it's the wrong result.
Of course, yeah. And so would multiplying all of these out, but then you're losing the practice with the product rule, yeah. So you gotta do a few of these with more than two terms to get used to the idea that product rule doesn't care how many terms there are to begin with. Okay, I like it. All right, so let's look at, let's do this problem together. This is going to lead into quotient rule. Let's see. Still don't like it, was too bad. So here, all I would do really is I would just divide each piece, right? But can you see how I could rewrite this as bring that up? Is that cool? So then it is a product of two functions, but one of them has a negative power on it. Which one? The one that was on the bottom, of course, because when I brought it up, it had to have a negative power on it. So that idea, if I look at this now as a product rule, what's going to happen? I'm going to take this guy's derivative, and then I'm going to leave this guy alone. I'm going to take this guy's derivative. Right? That's the rule.
Wouldn't it be minus?
No.
No?
Nope. Why? What's the rule say?
because-
Yeah. It will eventually become a minus because when I take this guy's derivative, a negative is going to come down. But the rule has a plus there. So then you get the derivative of this would just be 2x minus 7 plus a negative 1 comes down, so you can make it a negative. And then what's this guy do? So the negative 1 comes down. Now it becomes negative 2. I like it. I like it. And then you can do some more stuff with that. Right? So this does sort of become a minus. And notice, let me see if I want to give you guys a little preview. Doesn't this become this minus this? How would I put these together? I'd have to do what? Who's missing what? How do I get these together?
First term is missing an x.
First term's missing an x. And then I can plot those together. So notice how whatever the bottom was, it became x squared on the bottom now. So we're gonna prove the quotient rule, and then we're gonna use it a few times. Look at the top though. Isn't the top basically this function times the derivative of that function? Minus this function times the derivative of that function. That's what the top is.
Can you say that one more time?
Yeah. So this top is this function times the derivative of that function, isn't it? And what's this one? This is this function times the derivative of that function. That's what that is. I like like it. That's not a proof, it's just something to notice that just came out of this problem. Any problem I would have put down, it would have come out like this. And we're about to prove it. You'd hope that quotient rule would have elements of product rule in it. Because there is no division. There's just multiply by the reciprocal. So they should be related. Rules involving those things. So that's kind of nice. So how do I prove a rule? That's the one time I have to go back and use limit definition. So if I have given It's nothing new, right? I find the derivative of h. I put an x plus h into it, and then I put an x in it, and then I put the whole thing over h. I mean, that's the, take the limit. I love it. That's algebra. Believe it or not, right? You guys with me? So anytime you want to prove how things react, well, what if I multiply functions? We did this. We proved using the limit. What if I divide functions? Okay, we're going to do it right now. What if I put a function inside of a function? Oh shit, we're going to do that too. We're going to go back to limit definition and show a rule. The beautiful thing is when we learn, so we know one derivative rule really for a function. That's x to the n. We haven't learned anything else. There's a lot of other functions that exist, right? We're going to learn specific rules for derivatives of functions, and very often we're going to use these general rules for how derivatives work with each other. So we have product rule, quotient rule, chain rule. Those are kind of like overarching. And then we have, well, what if you have sine? What's its derivative? And so forth, right? So when you put those together, you can kind of like tackle almost anything. So, what the hell do I do here? So let me recall. How did we do this kind of thing? Do you see how that's related to this? Fraction, something. So how did we do that? That's pretty much exactly a problem we had on one of our little worksheets. Doesn't remember how we tackled that.
Take the limit of each.
Well, and then you notice what? So if you do put a 2 in,
That's a 0. Oh,
what's it become?
it's 0.
It becomes 0 over 0, which is not 0. That's an indeterminate. Oh shit, so we had to do something. Conjugate? No, there's no radicals. Factor? No, not really. So what do I do? What's the third thing we could do? What do you do when you have fractions inside of fractions? You try to consolidate them. Shit, yes, right? You try to put those fractions together. So you get LCD and all that kind of business, right? So let's do this real quick. This might be good. How do I put these together? What does this guy need? A 2. What's this guy need? X. What is 2 minus x divided by x minus 2? I love you guys so much. What's x minus 2 divided by x minus 2? 1. So what's 2 minus x divided by x minus 2? Negative 1. I love it. So I get the limit as x goes to 2 of negative 1 over 2x. So that's what putting those two separate fractions together does for you. And so you get negative 1/4. Okay, so how do I do this? The exact same way. Oh shit. So what's this guy need that he's got? G of x. And what's this guy need that he's got? I always love when I have a student that says, why don't you do anything to the bottom? I didn't really just do anything. I didn't do a damn thing, did I? I multiplied by 1 a couple times. Ooh. So that's why I don't have to do shit to this, because I didn't do shit to this. You guys with me? Hopefully, okay. So what do we get here? Let me see if you guys can do this. I don't need all these parentheses. Jeez. Is it cool? I'm divided by this and this, so let me just put them all together. I love you guys. Or divided by h is times 1 over h, so the h just goes down there with those. That's either way you want to look at it. And then I don't know if you remember what we did when we had product rule. We did something very weird that you actually end up doing a decent amount with theorems. Does anybody remember what we did with product rule that you would have never guessed to do? Something here in the middle, we brought stuff in. I don't know if you guys are like, dude, I have blacked that out, dude. You said I didn't have to worry about it. So guess what? I didn't worry about it. I was like, shit. This is a really good general thing to remember. It's not like it happens maybe 4% of the time. But it's really good to know this little trick. I'm going to add and subtract something. Oh, crap. You're no good. We'll go back to you. So I'm going to subtract something and add something. I'm going to subtract and add. That. So this is what I put in there. And I love you guys. You guys hate this shit. And I know you do, and I don't care. You have got to see where something comes from. It's nice to know a shortcut, but if you never saw where it came from, you don't know shit. Right? So you desperately have to kind of follow along with... Now, do you see what happened since I did this? What do these two have in common? G of x. So I could take a g of x out, and then I'm left with f of x plus h minus f of x over h. You should know that form. You should know what that is. So we put that over here. Go away, old problem. How you doing? Are you there? Yeah. Not too far over. So up here, I can take out of this part, I can take a g of x out. And then I've got that. See how I put the h up top there? And then I can do something very similar over here. I'm going to take a negative f of x out. Do you see why? For the limit definition, what should show up first? F of x plus h. So g of x plus h should show up first. So I'm going to take out a negative f of x so that I switch the order. And you see all those parts. G of x out, so you're left with, g of x out, so you're left with f of x plus h minus f of x over h. I know what that is. Negative f of x out, so you're left with that minus that divided by h. It kicks so much ass. So then what do I get? I get g of x. As h goes to 0, this don't give a shit. It ain't got no h. I love my grammar, but too bad. And what's this? Yeah, it's f prime. Minus f of x, and what's this? G prime. All over, as h goes to 0, what happens to this? It just turns into g of x times another g of x is g of x squared. Which is what I was saying earlier. That bottom became the square of what was on the bottom to begin with. Every time I show you a rule, I try to start off with a concrete reason why the rule isn't something simpler or why the rule is eventually what it is. So when we do chain rule, we're going to start with some concrete examples about why some of our guesses would be wrong as to how it works. So what the shit have we just shown? We have just shown this. This is what you really need to know. So if I have something that is a ratio of two other functions, then its derivative, I'm going to reorder that a bit. There's a whole song involved with this. I don't dislike music, but the more songs and little foil bullshit, it takes you further away from the idea. But if you already know the high D low, low D high song or anything like that, great. Sing that out, have fun. Here's my song for this. Top first. That's it, right? Top first. Why has this got a minus? Because G is on the bottom. What's happening in this term? I'm taking the derivative of G, so that negative is going to come down, just like it did in the example we did. So let's do a concrete example, Jeff. Please, dear God. Okay. Let's see. So you got to know this rule. You got to know product rule, and you got to know quotient rule. I like it. So here's an example. Yes.
I'm just wondering, what difference does it make when you put the f, the function? The
Not a damn bit of
derivative f
difference.
first?
That's why I did it. I just kind of like things in alphabetical order. Plus, this goes along with the way that I wrote Prodigal.
Well, earlier you said it's easier that way. I'm just wondering why.
Because it relates better to the way I write quotient rule, that's why. That's it. Not that it's easier calculation-wise. Not at all. But doesn't the top look a lot like Prodigal? The only difference is there's a minus. Why? Because that one was on the bottom, so it's going to have a negative power. So, of course, it's going to be minus on that. I like it. So it's harder to forget which term should have the negative if you really know in the first place why the negative is there. I like it, maybe. Why is the negative there? Because that term was on the bottom. When I take its derivative, the negative is going to come down. That's why. This shit, I don't care, right? Whichever way you want to do it, whichever way makes more sense, I love it. So here, if you wanted to, you can kind of do the parts of this. You can identify this as f and do its derivative, and g and do its derivative and plug it in. But let's see if we can do this. What's the rule say? What's my song? And now maybe you understand why the song is the way it is. My song is top first, right? So what's the very first derivative I do? The top. And then you leave the bottom alone. You never do more than one derivative within a single little thing at a time, right? Then you put what? Minus. And then F, you leave him alone. So now the bottom gets his turn. And what's on the bottom now? What's it say?
4x plus 1 squared.
Yeah, the square of what was on the bottom to begin with. I love it. This is the textbook way to do this. When we learn chain rule, I'll come back and show you the way that young, foolish Jeff did this. Quotient rule is important, but when I learned it, I didn't like it. I just automatically took whatever's on the bottom, I brought it up top, made it to a -1 power, and just always did Prodigal. You could do that. It's just not really that much quicker, to be honest. And quotient rule is important to know, as I found out later. All right, and then if I want to clean this up, what is this guy's derivative? Let me bring this up here. I'm running out of space over there. What's this guy's derivative?
4x.
4x times 4x plus 1 minus this guy. What's this guy's derivative?
4.
Just a 4. I like it. Just a linear function. All over this business. Don't ever square that out. Don't ever like foil that sucker out. Just leave that poor dude alone. Sometimes you'll actually cancel with something. Can I cancel something with him right now? My God. My God. Can I kill one of these? I kind of gave it away a little bit. Please stop doing that kind of stuff. That's a Math 90 level mistake. Why can't I not cancel one of these? Because there's a freaking subtraction. Can division kill subtraction? No. It's not its job. So too bad. You can't do that. Right? I always have somebody say, I had it. It was much easier for me to do than what you did on the board. I'm like, because you did it wrong. So that's very often easier. So what do I do then? I distribute. Start getting like terms together. Here it's going to be minus 8x squared plus 12. And then I finally get 8x squared plus 4x plus 12 all over 4x plus 1 square. And then you do have to worry, is this factorable? I don't know. Let's see. So I can take a 2 out of the top. Is that cool? So there are no factors of 24 that add to be 2. So that ain't going to factor, so I can just stop. Like any time you get a fractional answer, you have to see if it reduces. I don't care what class you're in, right? So sometimes that might actually reduce. It might. All right, let's do one more of these together, and then I'm going to give you a couple to try on your own. I never forget that, this is, when you're in calculus, you can't forget this. The limit definition of derivative comes directly from algebra. We just threw one little extra thing in, which is kind of a big thing, to be honest, the limit idea. So we can have 1 point. We can pretend like we have 1 point when we really always have 2. Are you guys with me? So the limit definition of derivative came from algebra. We just kind of got around needing 2 points by pretending we actually got 1 point, by using the limit. Is that cool to say later? You guys with me? Because that's where that came from. We developed product rule and quotient rule using the limit definition, which comes from what slope is. I mean, that's, right? So you're going to use these rules. Part of your brain is going to start to go, why does rule work? They just said it did. Let me just do this shit. But you have to take control. You have to take ownership. I know it works because it comes from basic algebraic idea of slope. That's really where it comes from. You guys understand what I'm saying? Very often I get students, I can tell that's what's going on. They kind of like lost faith, but they're kind of like, I'm just going to do it because they said to do it this way. You know where it came from. So what if I have this guy here? What do you got, Jeff? I don't know. Let's do one with some funkiness in there. All right. So what's the rule say? Top first, 11. He gets his turn by himself. minus, and you guys can all see that prime there, right? It gets lost sometimes. Now the top had his turn already, so get off the slide, somebody else's turn. And then the bottom gets his turn. And of course, what goes on the bottom of the whole thing? I'm just going to write it, and then you guys agree. All right. So it's just the square of whatever was on the bottom to begin with. Okay. And now you just start doing the derivatives. I like when you write the rule without actually doing any work. I didn't really do any work. I just rewrote what the rule says. Now I'm going to do the work, so then my whole universe right now is just that piece. The more you can break up any math problem into smaller parts, the easier the whole thing is. How do you take the derivative of this dude?
Half x.
Half x,
-3/2.
negative who to what?
Negative 1/2.
Yeah, negative 1/2. And the 2, of course, goes away. And this guy's just sitting there. This guy's derivative is going to be very similar. It's going to be 3/2 x to the negative 1/2. Of course, the negative 1 goes away. So rule, then take derivatives, and then it's just cleanup. So this one step is the calculus step. Everything else isn't really calculus step. Now you just clean things up. You can distribute. Right? What do we get here? Let's see. 1/2 times 3 is 3/2. What's x to the negative 1/2 times x to the 1/2? What's x to the negative 1/2 mean? 1 over x to the 1/2, right? So what's 1 over x to the 1/2 times x to the 1/2? 1. What's negative 1/2 plus 1/2? Because you add powers when you multiply like bases. Negative 1/2 plus 1/2 is 0. What's anything to the 0 power? 1. Minus, that's what this is, minus this. Got my whole 3/2. Minus. Then you distribute this. I get 3/2, and again, I get just 3/2. Right? X to the 1/2 times x to the 1/2 is 1. Minus 3 x to the negative 1/2. All over this craziness here. This cleanup shit should be where you can sink your teeth into it and just go to town on it. But this is where people sort of like, now, do I have any like terms? Yeah, the 3/2 want to die. Go away. And then I get negative 1/2 of these minus 3 of these. Yeah. So you get negative 7/2 x to the negative 1/2 over this business just sitting down here watching all the weirdness happen. Now there's one last thing. If you left it like that, I'd be okay with it. But you see how much wants to go on the bottom? The 2 is on the bottom. The x to the negative 1/2 wants to go on the bottom. So you could rewrite this as negative 7 over 2x to the 1/2. If you stop there, I'm okay, but I mean, there's still a little bit more you can do. You normally don't stop with negative powers. All right, so let me give you guys a couple to try.